I think we're going to get. I think we're going to get started. That clock is a little bit behind, but
You're gonna run
actually
it?
it's past 1:30. So welcome to everybody who's made it here today for a very special, distinguished lecture from Dave McLellan. Uh, I'm Bob Iannucci. I'm on the faculty of the Electrical and Computer Engineering Department here at Silicon Valley. We are very thankful to our sponsors, Yahoo and the Department of Electrical Engineering, who sponsor this series. The purpose of this series is to bring exceptional people to this campus who can help us convey to our students the magic and the excitement of engineering. And I have the pleasure of welcoming my friend, Dave McLellan here. Dave and I met back in the early 1990s when I was working on a little company called EXA Corporation, which is now public, by the way. I knew very little about the automotive industry and how the business of making cars actually worked. But we thought we knew how to do aerodynamics. I met Dave as part of the process of meeting the folks at GM, and more broadly, Dave and I and the EXA team. Dave educated us about how the car business actually works. We've stayed friends over the years, even though we've been at quite a distance. And it's a real pleasure to have him here today. So some of you will know Dave as the former chief engineer of the Corvette. And thank you, by the way, to all of you who brought your cars here today, some to get them signed. I saw Dave signing dashboards. I thought that was really cool. But some of you, some of the students here and in the overflow room, there's a hidden message here. One of the reasons that I think Dave is such an exceptional person and worthy of being called a CMU Distinguished Lecturer is he's a system thinker. Dave approached Corvette from the perspective of not just a vehicle, not just a suspension system, but as an entire system. And we value that here at Carnegie Mellon University. So my challenge to the students who are listening today is listen to what Dave says from the perspective of thinking of transportation systems, automotive systems, and the ability to take something that's big and complex and break it down to something that we can understand, that we can apply some theory to, that we can improve and then measure and take it, put it on the test track, and see amazing results. So I'm sure you'd rather hear from him rather than from me. So please join me in welcoming Dave McLellan. All yours.
Thank you, Bob, and thank you, Steve, for hosting me. Delighted to see all of you folks here, and there's folks that we don't see that are upstairs, so welcome to them as well. What I want to do today is probably three things. First, I want to talk a little bit about driving automobiles in public roads and where in this digital age that might be capable of going. And then talk about the Corvette. That's kind of the hook that got a lot of you here. And then open it to questions. And so be thinking of good questions as we go along. And if I can't answer, probably be unanswerable questions. So let's get started. This is one of my favorite Corvettes because it changed for us how we think about the Corvette. We code-named it ZR1 from 1990. We code-named it the King of the Hill. And it turns out that was really serendipitous to do that because it really got the Corvette team thinking at a dramatically higher level in terms of what was possible and what they could do. They could do that. They could do anything, which is where we went from there. And you see that all the way out to the 2016 Corvettes that are just coming onto the road now. Those are truly exceptional cars that are being designed by very talented, exceptional people. And I apologize for saying it this way, but you wish that GM had that kind of esprit de corps and capability all through its organization. It's got pockets of it, and certainly the Corvette is one of those pockets. Next slide. I guess I get to do it. Yeah. Yeah. I want to talk about driving cars on roads. When you do Corvettes, you have to be out there in the road space with everybody else. And these 200-mile-an-hour capable Corvettes, in a way, it's a waste of time and energy to have a car like that when you can only drive it in roads that are speed limited and cluttered with traffic. And there's, there's nothing you can do about it other than you might be able to drive at 2 a.m. and get to the open road. But I'll talk a little about that as well. This chart to me is really interesting. It shows, it's a NHTSA chart, and it shows the fatalities over a number of years out through 2012 and a projection for 2013, people killed in automobiles. And it shows that it's come down as a result mostly of technology, but it's still pretty high, 32,719 in 2013. Think about that. If you divide that by the number of days in a year, that's 90 people killed every day. And now think about if that was if we were doing commercial airplanes, that's a DC-9 going down every day, killing all its people. And we wouldn't put up with that for very long. We either would quit flying in airplanes or we would fix the problem, whatever it is. And my sense of this is that it's just lingered so long. It's lingered for the lifetime of the automobile, and we needed to be able to move around and be transported, so we put up with it. Also on the graph is the rate, the fatality rate. It's that yellow line, and you can see that it's coming down. It started at 5.39, and it's down to 1.10. So it's come down by half an order of magnitude, which is really pretty amazing, because every year we have more cars on the road, we have more drivers, and yet the accident rate, the fatality rate has been fairly steady, but the fatality rate per mile driven has gone down substantially. So the question for the academic community, among others, is how do you drive that down further, and how do you drive it down faster? And are there things that we can do in this connected digital world that we're building that will truly improve that? And when you look at the fatalities, one of the best studies I've seen, it's an old study done by a group that included GM and UMTRI, University of Michigan Transportation Institute. And what they did was they looked at 15,000 accidents and divided them up into 100 different categories, and they call them buckets. You just put the accidents in the various buckets, and you measure the accident in terms of the injuries caused or death to try and put some measure of severity on it. And you can and they coalesced that down from 100 to 44, and they published it as 44 crashes. And then if you look at 44 crashes, you can get it down to about two main buckets. And the two main buckets are city streets and intersections, left-hand turns, and that's one of the buckets. And the other one is just rural roads, two-lane roads where you got traffic passing at, well, if you're going 50 miles an hour, the closing speed is 100. So if you run into, if you have a head-on collision or you run off the road in rural roads, you got problems. And running off the road is not a good idea, I will tell you. It may save you for a moment, but the next moment when you're driving in that off-road environment with ditches and all kinds of obstacles, it's truly a mess. And yeah, you get in serious trouble there. Okay, go ahead. That's me. Let's see if that works. This is really interesting. But gosh, it must be 3-4 years ago now. I met with some of the Hella engineers from Germany over lunch, or actually it was over dinner, but it doesn't matter. And I said to him, you know, you've got all the tools that you can put together a system where you have controlled lighting to not only illuminate the night, but to illuminate potential problems that the driver has to deal with. And what they've come up with here is a scheme called their Matrix LED lighting system, and it's a whole series of headlights, and left and right. And then with a sensor suite, they can turn those up or turn them down in response to conditions. And what they're trying to show here is on the left, conventional lighting system and what it'll light. And particularly on low beams, you've got to keep the light off the oncoming car, and you really don't want to put the light on the car that's ahead of you. All you do is annoy the guy. And so what they have done with this LED matrix is, as you can see, they've turned the illumination down on the car that's coming toward them, and as it gets closer, they turn down and turn up lights in the array accordingly. And then you also can turn down the light that's shining on the car ahead of you, because you don't need that. But what you really need to know is pedestrians and motorcyclists and bicyclists and animals, you know, all the things that you normally don't see very well in the night. And I think they're on absolutely the right track. And what they're doing keeps the driver's attention in the driving space. It's not a head-down display. It's not even a head-up display where you have to refocus in front of you at the front of the bumper and look down at the bottom of the windshield. This is right out there. And someday we'll figure out how to do the same thing for day driving to help make it safer. We have a video. You ready to do that?
I just want to show you also to advance the slides. Yeah, with the video now?
Yeah. Just start it and then stop it. That's what I would have you do. So we get to see the scene. What we're going to look at here is a stoplighted intersection with cars stopped in the one direction, waiting for the cross traffic to do its thing according to the stop, caution, go traffic light system. And it's just Normalville. Well, are we close?
Yeah, we're getting there.
All right. Well said. Yeah. Well, whoa, it happened too fast. Yeah, so there was Normalville, and in a second, yeah, nobody was expecting it, and all of a sudden, this guy in his big Ford truck comes roaring into the intersection against the red light. And it's that kind of stuff that, and lots of others, that make intersections dangerous. Yeah. And you can see the amount of energy that's involved there. It's not a trivial cars bumping into one another situation. It's enough to tip cars over, and I don't know what happened to the occupants in those vehicles, but it's a smashing mess. But what it points to is a fundamental issue that we have with the automotive driving scene, and that is it's not fault tolerant. It's it grew up from the early 1900s when cars started to populate the roadways and replace horse-drawn carriages and wagons, and speeds started to go up from 10, 15 miles an hour to what we see here. And in the old analog world, I'm not sure how you would make that system very fault tolerant, but we certainly didn't. And it was better than nothing. You know, control of intersections is important. But when drivers make mistakes or are inattentive for whatever reason, this is the kind of stuff you get. And that's where that 45,000, 33,000, whatever the numbers is, fatalities per year. And by the way, the number of injury accidents is probably, it's about 2 orders of magnitude bigger than that. And the cost of accidents is outrageous. I mean, it gets spread around so many places, but it does show up in your insurance and your car insurance. And it's about $1,000 per year per car. So if you have a car for 10 years, that car, you've paid out roughly $10,000 to the insurance company for protecting it from these kinds of accidents. And some of the injury stuff is in that 1,000 also, but then your Blue Cross or whoever your health insurance is with, that carries a piece of that as well. So it gets buried over in another pocket. So you're not that aware of how much of it is due to automobile accidents. But these are huge numbers. Okay. Did I go the wrong way? What am I getting?
Oh, sorry. These little buttons down here.
So you want me to use the screen?
Yeah.
Okay.
Oh, yeah. Sorry.
We will persevere. Yeah.
Actually, that works.
Yeah. Okay. If that'll work, I'll just use those buttons. This is the picture that came from the Hella business, and it shows what I just described to you is with that array of lights, you can turn lights up and turn lights down at will, if you know where the road ahead is going and where those objects are in the road that you know are normal, that you don't need to over illuminate. But as you think about those, if you think about the Ford truck accident at the intersection, and you think about this stuff, you can go from Normalville, and everything is copacetic, to a catastrophic accident in little more than a second. These are really fast occurrences that happen to you. It's not nobody sitting there in their cars waiting for that light to change or crossing the intersection really had any idea that there was a Ford truck coming at them. And at the speed he was probably going, he could have stopped in a second or two and avoided that. But he didn't. I don't think, it didn't look like he even slowed down. So that's part of what we have to deal with here, is these accidents having a very short window, very short. Let's see if this works. Well, yeah. I want to talk, second part, a little bit about the Corvette. And I know that's why a lot of you are here, and it's probably one of the reasons I'm here as well. That's how the Corvette started. And it was the vision of Harley Earl, and it really came from the interest that his son Jerry had in European high-performance sports cars. And it seemed like it was Harley's idea to get his son's attention back on the U.S., and so they produced this show car they ultimately called it the Corvette. And the car went from a design concept to production in a very, very short order. And the early ones show it. They're really, in many ways, very crude cars. And the chassis for it came out of the Chevrolet convertible parts bin. It was done by Maurice Ollie, who's Zora Duntov's predecessor. And they shortened the chassis and changed the rear end because of the much shorter prop shaft between the transmission and the rear axle. They had to make some changes to the front of the engine to fit under the hood, and there were some other changes, but those were the major physical changes to get a running chassis underneath the car. And there was a lot of, it's one of those cars like we've seen over and over again, where there was an initial excitation about it, and everybody wanted, well, I should say everybody, there were lots of people wanted them, far in excess of what they were planning to build. But when they got into production and people saw what they were building, all that seemed to fall away, and within the year, they couldn't give the cars away. And as a result of that, Chevrolet was planning to cancel the Corvette. That was the first time, I should say, that was the first time they were planning to cancel the Corvette because they just didn't know how to make it work. And I don't think they understood what was wrong even. But that's not what happened. At about the same time that Chevrolet came to production, Ford heard about it and started the design of their, what became the 55 T-Bird. And so by the time Chevrolet decided that they were going to bail out on the Corvette, the T-Bird was in production, and Chevrolet realized that if they were to cancel the Corvette, it would be quite embarrassing to them, given that Ford was quite successful with their initial two-passenger T-Bird. Corvette in that first year and a half sold probably about 1,800 cars, and then the market stopped, and they had 1,100 cars sitting at the plant that even the dealers wouldn't buy, and so they had a problem on their hands, and that's why they wanted to just quit. Now, as I say, that didn't happen because of the Thunderbird, and then also Zora Duntov, I have to give him so much credit for seeing value in the Corvette first at that Motorama show in New York, where they showed the prototype, and then working his way into Chevrolet and R&D, working for Maurice Ollie, ultimately working for Ed Cole, who was the chief engineer of Chevrolet at the time. And Cole wanted the Corvette, although I don't think he really understood the car very well either. And it was Duntov that started to do a series of performance runs with the Corvette. This is the run they did at Daytona and achieved speed of 150 miles an hour, which when you think about the tires and everything that was available to them in that era, that was pretty exceptional. And it did set a bar for the Corvette that was very useful and very high. And I'm just going to show you some of the racing stuff that Corvette got involved with, because it really sets the tone, sets the image for the car. And when you wonder, why is the Corvette what it is today, it's the tie to all of these experiences. This is the Sebring in '57, I think it is, and by then they had actually placed pretty well in '56, to their surprise, and by '57 showed up with a car that was totally undeveloped and ill-prepared, but was very fast as long as it lasted, which was not very long. And then, unfortunately, the Automobile Manufacturers Association put a kibosh on the GM bought into on support of racing. So all of the racing activity from there for another couple of decades had to go underground. This car, the Stingray, was actually built from the mule version of the car I just showed you, and it was raced for a number of years. not supported by Duntov, paid for by Bill Mitchell, who was one of the stylists at GM that ultimately became their VP. Duntov in R&D used some of these, I'll call them mules, to develop future technologies that found their way into the Corvette. The Serve 1 here was the mule to develop the trailing arm rear suspension that was on the 63 through basically 82 cars. And then we modified it for the C4s, and then it became a regular five-link system on the C5, 6, and 7s. He also did a series of cars in R&D that were lightweight cars with tubular frames based on the production 63 car. And those also fell in under the ban and were squirreled out to racers, and were, I think, reasonably successful racing against Cobras. That was their big competition at the time. The Cobra is an extremely light car, and that was what they had to do. The production car was just too heavy. Another interesting car that he did that was really leading toward trying to solve the next generation of Corvettes. It's a mid-engine two-place configuration with an automatic transmission in the back, and then you can't see it, but there's also an automatic transmission ahead of the engine that drove the front axle, and each of those automatic transmissions was uniquely calibrated to its job, one to do the rear driving and the other to do the front driving. And this is all back in the analog days. You know, nothing to do with good digital control where you can almost make anything happen. All of that led through a series of mid-engine design proposals to this show car that was done at design staff. It actually has they're not open here, but it had bifold door openings that were curiously interesting, but if you want to roll the window down, you have to open the door. I've had that experience. But it was designed by Jerry Palmer and Henry Haga. Actually, Henry was the chief designer. Jerry was his working designer. And out of that experience, Jerry really developed what became the C4s. We didn't call them C4s back then. All that came on a lot later. But very early in the C4 program, we found that SCCA was doing a showroom stock series of endurance races, 6, 12, and 24-hour. And they made a class for the Corvette, Porsche, and Nissan, and I think the RX-7 was allowed in that class also. And it very quickly became a contest between the Corvettes and the Porsches. And that lasted for 3 years. And Corvette won every one of those races, which was really interesting. 24-hour race is a chore. It is hard work. And it was interesting that we were able to prevail against the competition. Not by much. In one of the races, in '86, we had just introduced analog brake control in the car. And we actually had a driver training instructor who was also a racer, John Powell, instruct all the race drivers on how to use ABS. And initially, they didn't want to use it. I mean, this is not the kind of He-Man stuff that they're used to. And John and ourselves basically told them, you're going to use it. Trust us, believe us. And they did. And we even had one driver come back into the pits during a race and said, my ABS light is on. We told him, get the heck back out there and race your car. And we'll fix that after the race. So he just had to drive with the foundation brake system for a while. But at Portland, I think it was a 6 hour. It was intermittent rain, and Porsche was leading, and there was a Corvette right behind him, but couldn't get around. I don't think it was fast enough to get around. And late in the race, the rain started, and it always starts on one end of the course or the other. It never is, everywhere all at once. And the Porsche goes into this turn and spins off in the wet. And the Corvette guy sees what's happening, uses his analog brake control to get slowed down, and takes the race. Win them any way you can. We also had a number of performance things that we did to inspire the troops. This is the Callaway Sledgehammer, and you can see it set a record at TRC in Ohio at 254.76 miles per hour. It was driven by John Lingenfelter for that run. And when you see the video of it, I mean, that is moving fast for something that's moving on the ground. And there's also there's a couple of really good videos, YouTube videos on this car if you're interested. There's one where the chief engineer for Callaway, Tim Good, talks about the car and driving it to TRC, and then working in the garage along with the NHTSA guys. And when they first got there, I think it would only go about 220 miles an hour. And so Tim was continuing to work on the car to get it to what he expected. He was looking for 250, and was confident that he would get there when they got everything sorted out. And somebody from the NHTSA side asked, well, how fast do you want to go with this? And he said, 250. And then he said, at that point, they started to really shun me. That they couldn't believe that anybody would drive on their big oval track at 250 miles an hour, and they thought he was just absolutely crazy. Maybe he was, but not in the Corvette world. We also did a really interesting experiment with the Chevrolet marketing guys. It's always hard to bring those guys along because they're so accustomed to just marketing ordinary passenger cars and trucks. And so to get them thinking about the Corvette is really tough. But we had a number of turbo Corvettes ourselves. I think we had 6 twin turbo Corvettes, about 600 horsepower, and not as fast as what Lingenfelter and Callaway built ultimately, but they would go 200 mile an hour plus. And so we set up a little session at the Desert Proving Grounds when the marketing guys were out there, and there's a straight stretch of road with loops at either end so that you can do a continuous loop. And we parked one of our twin turbos at the beginning of the straight, and had our bright red Lamborghini Countach circulating at 120 miles an hour. So it was going pretty fast by itself. And then we staged the marketing guys a mile down the road so they would see what happens after a mile. And so and we put one of our best drivers in the Corvette. So we knew what was going to happen and made it happen. But as the Countach came past the Corvette took off, and of course a mile away the red Countach keeps getting bigger and bigger and bigger quite linearly, and the Corvette looks like it's just parked back there. It looks like it never moved because it has to go through all the speed ranges. And at the end of a mile, it's going 180 miles an hour, and it goes whooshing by the Countach right where these guys are standing. So I think we made the point. I know we made the point. We continue to support racing with the Corvette. Callaway runs mostly in Europe, although I think he may be able to bring this car into the U.S. Pratt Miller is the Wait a minute. I thought I had a picture of the, well, I did have the Pratt & Miller car in there someplace. Yeah, this is the Callaway version of the C7R, and it is very competitive in Europe. Racing today in these kind of sports cars is heavily managed by the series organizers. And so they try to balance the winning capability of this car versus that car. Although, so then politics enters the picture as a very strong dominant. But Corvette's been able to do very well against Porsche and BMW and Mercedes cars, and I give Callaway huge credit for helping us to position the car in Europe. Plus, the Pratt & Miller wins more often than not its class at Le Mans. And that 24-hour race is, that's a, well, it's as tough as any of the races that we ran Corvettes in for 24 hours, although you have, in the case of Le Mans, you have other cars passing you all the time, you know, the prototype cars. So you're back there in the pack, and you got to watch out in very different ways so that you don't get run into, and that happens. The outgrowth of the turbo program and what we had shown the marketing people, and also gotten Lloyd Royce, who was our general manager at the time, went on to become president of GM. Lloyd drove the turbo cars on the road and was enamored with what the possibilities were there. He really wanted, for marketing reasons, I think, more than anything else, to do a performance engine for the Corvette naturally aspirated. And you know, I wasn't going to argue with him. Why would you? If he's willing to spend the money to get what became the LT5 engine, God bless him. So we didn't go the turbo route back then, and we gave it away to Callaway very purposefully. And the venue for the ZR1 is really limited. By the time it was in production, the racing series that it could be involved with, I think it's called the World Challenge. They were balancing cars by putting huge amounts of weights on, and the ZR1 had to carry, I think it was well over 1,000 pounds of weight. And when a Corvette enthusiast sees his car just barely competitive with other cars, he's not really, or she is not really aware that it's carrying 1,000 pounds. So we looked elsewhere, and one of the places we looked was the 24-hour FIA world record, and we took that record as well as a number of other related records down in Texas at the Firestone Proving Grounds. And that was another amazing adventure. Chevrolet, well, we asked Chevrolet if we could do it. And we put as much pressure on them as we could, saying, it'll work. They didn't believe us. They were worried that if it didn't work, it would be an embarrassment to Chevrolet. And so we got them to finally agree that they would not stop us from doing it, which is not as negative as you can come into it. And so we did it, and it worked fine. The car ran for 24 hours at 3/4 throttle, roughly. Ran 175, 885, and at the end of the 30 hours, because we took it out to 30, the guys took the block out from under the throttle and ran to full speed. It was about 190 in that car in that configuration, and it was in a actually it was in a fuel economy configuration. You can imagine that, because you spend time with the car running on the road, and then you spend time with the car sitting in the pits while you're fueling it. And anything you can do to make the runs between fuel stops longer, the better off you are. And the FIA does not have a lot of rules around the record runs, other than hard parts. If you have to change hard parts during the run, they have to be parts that are in the car. So there was a small FIA suitcase in the back that had some hard parts in it. We never used those hard parts. We did use a hose, but that's another story. And that's why the 30-hour record was 2 miles an hour slower than the 24-hour record. Amazing run. All that and our connection with Lotus led to thinking seriously about what could become the next generation Corvette. And it really came down to an architectural problem for us. We could achieve 4 out of 5 major categories of performance with the C4. We couldn't do all 5 at once. And what we were trying to do was produce a 2-passenger convertible, although they're also coupes, with improved entry and seating, no heavier than the existing car, and with the first torsion mode of the structure at well above wheel hop instead of just below wheel hop as a convertible. And when you look at how competing manufacturers had solved parts of that equation, Mercedes with the SL, which is a convertible with an aluminum engine and magnesium seats and a lot of lightweight parts, still weighed 4,127 pounds, contemporary of this car. And to get that 600-700 pounds of weight out of there, you had to do some really clever engineering. And the Lotus guys agreed with us that we really needed to design the car with a backbone structure. We truly didn't know how to do it because we had this automatic transmission that we couldn't afford to replace with anything else as a transaxle. So we really struggled for about 3 years in Chevy R&D to find the right solution. And the right solution turned out to be how the C5 was architecturally organized. And it ties the back. You can see here in a sketch that I made that shows better the intent. You've got this center backbone, which is very stiff in torsion, and that's what you're really relying on for the torsion integrity of the car. And why do you need torsion integrity? You need it because wheel hop is at about 14 hertz, 14, 15 hertz in a Corvette. And you've got, in order to have wheel control at 15 hertz, you really want to have a car that is higher natural frequency than the 15 hertz, so that the car acts on the shock absorber like a brick. And that's where we were headed with this. We originally, as an aside here, we originally did not design the C4 as a convertible or as an open-top target, but that was thrust down our throats. It's in the book. It's one of those things you just deal with. But anyways, there you can see the triangulated structures that we used to tie the backbone into the outer structure. And it turned out that structure, boxed structure in the rear was big enough to hold the fuel tank. So the cars have had a fuel tank in 2 parts from C5 on, and very, very well protected, well within the structure of the car. And the C5s came in at about 3,300 pounds. So that's what we were trying to do. And one of the objectives of that C5 program was to achieve ZR1 performance with the standard car, and you couldn't do that with the C4. You had to make some real steps forward. And the aluminum engine was one of those steps. Getting to the transaxle was the other one. When we first proposed the transaxle, um, we got a tooling bill from the hydromatic division for the automatic transmission. Manual was not an issue because you build unique manual transmissions anyways. But the automatic, we were taking advantage of a much lower price of a conventional automatic transmission. And so they came back with a tool bill that was probably half the cost of the whole car, the tool, $80 million. And that was hard to swallow, but we kept on. And what our engine engineer who was assigned to the program ultimately sorted out was that the four-wheel drive truck guys needed all the attributes, important attributes, that we wanted in this automatic transmission for their trucks. And so in the end, they got to pay for it because the tooling is allocated by volume. And Corvette paid some, but the majority of it was paid for by the truck guys. And then they got something out of that as well. They got engines that you know, the small block, 6-liter small block, has more power and torque than big blocks, and dramatically better reliability and fuel economy. So they didn't use the aluminum engines right away, but they're now starting to really take advantage of those aluminum engines as they move forward. A couple of pictures. This is the C7 that's in production now, and there's a couple examples out there. That's a second generation all aluminum structure. The first generation that was done for the C6 basically used the configurations from the steel in aluminum. And here that was completely rethought using extrusions. You can see all the straight sections. They're all extrusions. There are castings. The front suspension area there, that curved section is a casting. And it's amazing when you use castings, you can control thickness and put thickness exactly where you want it to be. And they were able to do that here. So that in the front and the rear has actually made the C7 aluminum structure considerably lighter than the C6 aluminum structure, and of course lighter than the steel structure. So they've made some real headway. A lot of that they've put back into bigger brakes and bigger tires and wheels, go fast stuff. It's important. So they've been able to hold the line on weight, not get it reduced substantially, but that's the trade-off that they're looking to do. There's that powertrain that's pretty much common from C5 forward. It's a torque tube with a drive through the middle of it. The manual transmission clutch is at the front. This is an automatic, and it has the torque converter at the rear. Yeah, there's the C7R that Pratt & Miller is campaigning. They campaigned it at Le Mans and won. They started with 2 cars, and they lost one in a horrendous accident. Apparently there was some piece of debris on the driver's floor that got under the accelerator pedal just at the moment when he was trying to get slowed down, and he didn't. So he had a big accident, and they had to run with just the one car. Future of the Corvette. I took this picture at a concours, and I wasn't planning that what I see here would happen, but I saw it when I saw the picture. There's a C7 Corvette right behind this GT Ford, and that's a production version of the Ford GT40. And the form of the 2 cars is amazingly similar. I'm looking at it greatly distorted here from off to the side. But the front wheels on the Corvette are very forward, and they're quite a ways back on the Ford. The shape of the windshield, the length of the hood, although there's no engine under the Ford hood. At the front, the shape of the windshield, its angle and length, and then the form of the car as it goes to the rear, very similar, very similar. And when you ask, there's a lot of discussion about the next generation Corvette becoming a mid-engine car, which is possible. If there are positives and negatives, and you can see one of the big negatives here is, and the Ford is not as extreme as a Lamborghini, but you literally give away the outboard foot space and have the driver and passengers sit very skewed in the car in order to miss those wheel wells. And those wheel wells are gigantic because they use big wheels and tires, and they're wide, and they have to be able to turn. So I don't know the answer. I mean, I'm on the outside looking in like everybody else at this point. But if they are going to a mid-engine, I hope they get enough visual differentiation with what they're doing to get people excited about it being different. And I hope that you don't have to have an operation to have your left leg shortened in order to drive the car. Okay, let's now turn to questions. Who's got a question? Oh, right back here. Sure. Excuse me.
I think of Corvette as a pioneer in the use of composites and plastics in the
Yes.
car body. Based on that experience, I wonder what your thoughts about additive manufacturing, 3D printing, as they call it, in the future for automotive are.
Oh, good question. First off, the fiberglass was originally, well, the car was originally intended by top management to be a steel body car. And just a curious piece of information. And the decision was made at the Chevrolet level to ignore management and do it in fiberglass, although they did it first in single-sided tooling, and it was very rough. And it was done at the absolute last moment, so it was not done well. Over the years, it's gotten better, and they've now learned how to do chopped fiber, carbon fiber, in essentially the same methodologies. Additive manufacturing, I think it's got a huge potential, huge. We use it to make parts that look like the real thing first, out of plastic, but then I'm not. You probably know more about that than I do. But you can make parts out of sintered metal as an additive process. So there's no limit. It's whatever your imagination will carry you to when you think about that. As I see very little limit in terms of what you can do to better manage the car digitally. I think we've seen a lot of that, but we're going to see a lot more. For lots of different reasons. Traffic flow, for safety. So yeah, the digital world has brought us a new opportunity that those of us who grew up in the analog world have a hard time switching. I mean, it's hard to switch your mind to, we always did it this way, we're going to keep doing it this way. To switch from that to new ways. And additive manufacturing is one of those. It truly is. So get busy. Maybe you are. Yes, right here.
I found it kind
Excuse me, you can also push the button right there.
in whatever it was, 57 or so, when they had when the big three went to the ban on factory-supported motor racing.
Yeah.
It seemed like GM kind of went on one direction, and Ford and Chrysler didn't care. After they signed it, they went the other way, and GM just fought that for years and years.
That's
and
right.
Everything got done under the table. It's
Well, and when
why
I
was
say
that?
when I say under the table, I mean really under the table. The guys that were running GM in so much of its history were either manufacturing guys or bean counters, finance guys, and they had no idea of how cars were sold. It really comes down to that. They are not sales and marketing people, and so you see all these, I'll call them crazy decisions that get made that are sub-optimizations. I mean, to stop all racing is like saying back in that era, stop all your dreaming, stop all your advanced thinking, just keep pumping out the old stuff, and that was not a healthy thing. Now they had to go underground because the bean counters sicked their own IRS literally on the division, so they had these bean counters wandering around checking to make sure nothing got spent and nothing happened. And it was only because Chevrolet R&D was a locked facility within an operation that they were able. And the guy by then running it was not Duntov. Duntov, my predecessor, was way too visible. If you see Duntov at a race, you know that something's up. And so, a very different kind of guy, but Frank Winchell ran R&D for a long time. And Frank was, he was really under management's radar screen. So, yeah, it's what it is. Yes, back here.
Yeah, the button is in the front. It's not the. Yeah, there you go. Yeah, and press and hold, please. Thanks.
I'm curious, the LT5 was a real big change for what Corvette had done before and actually has done in the future.
Right.
How, and it was a huge price increase in the car for that package. How on earth did you ever get that through corporate GM?
Good question. How did we get it through corporate? We actually owned corporate at that point, when you think about it. Lloyd Royce made the decision to do that, although you left the details to the rest of us. And he supported us through that whole process. And the price tag kept going up, because truly the engine guys who were managing it with Lotus and with Mercury Marine, they didn't know what things would cost at those low volumes. So this was a new adventure for everybody. And we added in the wide body on the rear of the car, which was not cheap. And through that process, Lloyd went from the general manager of Chevrolet, a vice president position, to group vice president to president of General Motors. And so Lloyd supported us. We had lots of detractors, including the general manager of Chevrolet, who thought we were crazy and thought Lloyd was crazy, and would have stopped it in a minute had he the authority to do that. When you look at when we started, Porsche had a V8 engine at about 250 horsepower. We were emission limited with the iron small block, and we were at 250, somewhere right around there. It varied up and down by little bits, but I would have to say that the GM, the Chevrolet engine guys who ultimately got sucked into being GM in powertrain, they were happy as pigs in swill at 250 horsepower. And there's another side to that, which is they didn't, and we didn't, know how to pass the California noise test with a high-performance, high RPM engine. So I'm going to tell you that story, because it's a good story. It's a California story. So we just, we did it. And we didn't know all the answers, and we knew that we wouldn't know all the answers until we built cars and could test, as whole cars. But we ultimately, got the engine working on the dynamometer the way it's supposed to, working in the car the way it's supposed to at about 400 horsepower. Started out a little below that, but just cleaning up the ports is good for 30 horsepower. Gosh. So, anyways, before we could sell the car, there's about half the jurisdictions in the United States that have these, we call them the California noise law, where you have to accelerate. You drive into this space at 30 miles an hour. There's a microphone off to the side, and then you accelerate in first gear. And no way in hell could the ZR1 pass that. But the European regulators had bought into a Ferrari strategy, which was called the Ferrari exclusion rule. And Ferrari was allowed to run the test in second gear. And so we came out to California, in Sacramento, and with our own GM regulator with us. This is not like Volkswagen and diesels. So we kept it honest. And we sat down in a conference room with the guys that regulated the pass-by noise test. And I think initially they thought we were trying to scam them, but we weren't. And I think that message came through. And the first thing we did was calibrate their noise meters for them because they were not calibrated. And then we all went out to the test track, and we had 2 prototype ZR1s that they could drive. This is where the chippies do their driver training. And so we had just a marvelous day with the regulators. And in the end, they bought, well, you guys can start, because you've got this skip shift business, you can start in 4th gear. How about that? So we were so damn quiet, we could have been noisier. That's what it takes to run a Corvette program. Right? You sense that now. Yeah, right here, and then.
I used to enjoy listening to your podcast. Is there any chance that you might
do some more?
Do some
yeah,
more?
I should do that.
Yeah, it was always very
Thank you.
interesting. Yeah.
Thank you. Yeah, over here.
You've said that one of your big disappointments was the cost of the ZR1. It basically doubled the price of the base car. Well, now the C6 ZR1 was almost double the price of the base Corvette. So does that change your feelings about the price on the C4?
No, it was expensive, but we had guys in the organization, Don Runkle, who was in Chevrolet marketing at the beginning of that, and then moved on as the director of advanced engineering for the whole company, the whole corporation. Don wanted us to make all Corvettes ZR1s, which was not a bad idea because it would get the engine up in volume to where the investment costs were amortized over a much larger number. And that's really what we're looking at. You got the cost of each part that you make, and you've got the cost of the tooling that goes into it. And it was done quite conventionally. There was no additive manufacturing, or there was some unusual tooling designs invested in there, but nothing as radical as that. Yeah.
Chevrolet has always tried to make Corvette a world car. It hasn't been very successful. Why do you feel that is? It's competition. They say it's competition. It's sporting. Well, they're definitely a world car. Chevrolet is only really accepted in America.
I can only guess. I've been to Europe with a Corvette several times, starting in '84, and Europe is a completely different marketing organization, and the GM of Europe, and they were working through distributors. So you take a Corvette to Europe, and it gets incredibly expensive very fast, and it has to go through this additional stage. And whenever the Corvette was hot, Chevrolet wanted them all. And
So the European organization, they had to take a back seat, and it didn't play well. I think it's better today, although I don't follow it that closely. The wins at Le Mans, it's over a decade now, and they win more often than not in the top GT category. So I think that has given them, it's given the name Corvette a very strong awareness in Europe, as well as what I showed you, the Callaway race cars. He's been racing for close to a decade now in Europe with Corvettes, and it's very competitive, very competitive. So the Chevrolet marketing organization is a 50-state organization. That's all. That's really at the core. They could care less about Europe or anything else.
Okay, so we're at 2:30. We will have obviously you brought your Corvettes. We want to enjoy that. We want to enjoy some more time with Dave, and we'll have some refreshments outside. Dave, we have just a little gift for you to
Oh, thank
remember
you.
us by, so that you can pack those car parts that never actually get used in something more decorative. And we also have so when you're not in sunny California, something to keep you
Just to remember
just a
it.
little bit warm. So
Oh,
let's
Thank
thank
you, Mark.
let's thank Dave very much for having come to talk.
Good.
Thanks very much. So again, thanks to Steve Ray, who lined up our Distinguished Speaker Series. Keep your eyes open for future announcements for the Speaker Series. We have sunshine and refreshments. Let's enjoy the day, and thank you all for coming and making this.
And I look forward to seeing all kinds of great automotive ideas coming out of CMU now.
Absolutely.
Yeah.
Right, great inspiration. Thank you again.
We shouldn't have those expressways out there being parking lots all day long.
Get things moving as they
Yeah.
should. Okay, great. Thanks again, and we'll adjourn to be outside.
All right.
Thank you so much. That's great.
There. Off. Yeah.
Very good.
Okay, great.
Thank you.
My pleasure.
So I will be.